The objective for this video is to learn to calculate a probability associated with a sample using the central limit theorem. According to the National Center for Biotechnology Information, the average age of Americans when Alzheimer's disease is first diagnosed is 74.7 years. Assume that the population standard deviation is 8.6 years. If a random sample of 35 patients who have been diagnosed with Alzheimer's disease is selected, what is the probability that the mean age of the sample is greater than 71 years? We must pay particular attention to the exact question that is being asked. We are not asked to find a probability associated with a single value. Rather, we are asked to find a probability associated with a sample size of 35. In order to answer this question, we must first understand the central limit theorem. The central limit theorem states that as the sample size increases without limit, the shape of the distribution of the sample means will approach a normal distribution. It is important to remember two things when using the central limit theorem. If the population is normally distributed, then the sampling distribution will be normally distributed regardless of sample size. If the population is not normally distributed, then the sampling distribution is approximately normally distributed if the sample size is at least 30. The sample size for this problem is 35, so we will use the normal distribution to find this probability. The question is asking us to find the probability that the sample mean is greater than 71 for the sample of 35 patients. We will use a z-score to find this probability. It is very important that we use the standard deviation for the sampling distribution, also called the standard error of the means, when calculating a z-score associated with a mean of a sample. The standard deviation for the sampling distribution is found by dividing the standard deviation for the population by the square root of the sample size. So we will substitute the sample mean, population mean, standard deviation, and sample size into the z-score formula. This will result in a z-score of negative 2.55. So, finding the probability that the sample mean is greater than 71 is the same in this case as finding the probability that the z-score would be greater than negative 2.55. It is always helpful to draw an appropriately shaded curve when finding probabilities associated with a normal distribution. Our z-score of negative 2.55 will be between z equal to negative 3 and z equal to negative 2. We are to find the probability that the z-score for the sample mean would exceed negative 2.55. So we will shade the region under the normal curve to the right of z equal to negative 2.55. Using a tool such as a normal probability table or a graphing calculator, we would find that the proportion of the distribution occupied by that shaded area is 0.9946. So the probability that the z-score would be greater than negative 2.55 is 0.9946. Another way to state this result is by saying 99.46% of all samples of size 35 among people diagnosed with Alzheimer's disease would have an average age of diagnosis that is greater than 71 years. In this video, we learned how to calculate a probability associated with a sample using the central limit theorem.